Let's look at the improvements that have come with build 0.2 alpha of the FullBody IK plugin for Unreal Engine 4. Now you can set up the constraint stores as separate data assets. The advantage of this is that now you can share the constraints across different rigs if they share the same skeleton. So now you don't need to go and set up the constraints individually in each one of your rigs, and that saves a lot of time. So let's dive into an example to see how to set that up. Let's set up a data asset. Choose Constraint Store as our parent class, and let's rename this to Constraint Store Tutorial 0_2. And let's quickly open it and create a new element. So another improvement that has come with this build is that you can specify the constraint joint names directly inside this window. So let's say we want to create a constraint for our pelvis joint. So earlier you had to go to the FullBody IK node inside your animation blueprint and choose the constraint joints there, and then you had to mentally match the indices in the array for elements here. So that caused a lot of confusion. So now that process has been streamlined by directly specifying the constraint joint names here, and there is no need to specify that in the FullBody IK node. So let's choose ball and socket and set our data and twist values and save it out. So while we set this constraints up, let's quickly set up animation blueprint as well. We'll inherit from anim instance and UE4 skeleton. Let's call it ABP tutorial 0_2. Well, let's quickly open it so that we can look at the skeleton hierarchy here while setting up our constraints. So let's duplicate this constraint and let's go to creating spine constraint, and let's make it a bit more flexible. Duplicate that to create spine 2 constraints. We'll leave the values unchanged. And then let's create spine 3 constraints. We want to reduce the amount of swing spine 3 can exhibit. And then let's create clavicle constraint for the left bone chain. And let's make it 20. Duplicate that for upper arm L. And let's make that more flexible. Maybe let me bring the twist down on clavicle here. And finally, let's create the lower arm, which is the elbow constraint. So it's going to be hinge. Let's make it controlled by the first and effector. So that's set to 0 here. And let's set the value of 30, something like that. So that's something you can play around with. And so these values, the theta and twist, should not matter for this constraint. So let's save it out. And let's save our animation blueprint out as well. And let's create a FullBody IK node, feed the output to the final animation pose. Let's bring in an idle animation and feed it to the input pose. And now here in the constraint joint details pane, we can choose our constraints, which we just created. And we should also remember to choose the root joint inside our node. So now, earlier in the previous build, if you compiled at this point, the plugin would crash because the root joint has not been specified. So now, with this latest build, the plugin does not crash. So it gives you an opportunity to fix that at a later stage. So now the final thing we need to do is set up our effector. So I'm gonna promote that to a variable and compile. So now let's go to the defaults value for the effectors and let's set up our effectors here. So we're going to create 2 effectors for this example. So we want to have an IK chain starting from the pelvis down to the left hand of the character. So another improvement that has come with this build, as mentioned before, is that you can directly specify the effector joint names here. So let's go and create this effector for our hand, and that's for our pelvis. So earlier that information used to come through a drop-down menu from inside the FullBody IK node. So that drop-down menu cannot be accessed here, but you can specify the effector joint names here directly. So that helps later when you're debugging or you're providing inputs to this effector transform, so you can directly see which transform corresponds to which effector joint name. So let's use just the input animation to drive the transform of the pelvis. Let's set a weight of 1, and let's set a weight of 0.1 for our hand. And let's set some values which make sense for the hand. To begin with, we're going to set up the location to be somewhere around this region. So let's see, 30, 30, maybe 110. And let's see how that looks after we compile. So yeah, as you can see now, the hand has been constrained. So as before, let's increase the size of our debug boxes. So let's make it 6, so that we can clearly see where our end effector is placed. So let's try to move around and see how is the hand effector behaving. So I'm gonna move it around. So as you can see, if we move the hand too far or at certain locations, it affects the spine bones as well. So what if so there has been a question that what if you want to restrict that motion and only if you want to move the hands? Then in order to create such behavior, we can create another constraint and constrain the spine 3 joint, which is located here. So let's go to our default values and create let's duplicate this effector, and the second last effector, let's rename that to spine 03. And let's also drive that from the input animation with a weight of 1, and let's compile. So now let's go to our preview values and try to move our hand, and now you'll see that the spine is going to inherit the animations directly from the input animation, and it's not going to get constrained. It's not going to get affected by the IK computation. So that's all we have to share for our current build. Please download the latest build and test it out, and let us know of your experience. Thank you.